This might be our last video on circuits. This is video 7, and if you have questions about any of the problems you find and you need help, all you have to do is just email, and there's going to be more videos on this topic, but for now this is going to be the last one. And in this video I want to look at the concept of the laws of Kirchhoff's law, and there are two laws, Kirchhoff's law. So one says that the branch represents a single element such as a voltage source or a resistor, and in the first law he states that for any enclosed loop, the total voltage, the sum of all total voltage in the loop is equal to 0. So if you choose a loop, you can choose this as your loop, or you can choose this as your loop, or you can choose this as your loop, or you could choose the whole thing as your loop. You could also choose your loop to be, so when you choose loops in a circuit, as long as every single branch is included at least once, then you chose the loops correctly. Direction of the loop doesn't matter either, so I can choose this loop, so those two branches included with these two resistors, and I can choose this loop and these two branches included in these loops with that one on the top. So I could have just two loops and every branch would be included. So for the first law, Kirchhoff's law, he says the sum of all the voltage, the sum of all the EMF or the voltage in or potential difference in the circuit is always going to be equal to 0. And we have been doing this in Ohm's law, where I tell you, like, when you leave the battery, that's how much voltage you have in your pocket. By the time you're done with the circuit, nothing is left in your pocket, so you have to lose all the voltage on every single resistor. And for the second law, he states that if you have a point, a node B, so the sum of all the currents that are coming into the node equals to the sum of the currents that are coming out of the node. So if I say this current is coming in, and this current is coming in, and this current is coming in, but this current is coming out, let me call this one I1, and this one is I2, and this one is I3, this one is I4. So what he states in his law is that I4 is equal to I1 plus I2 plus I3. The incoming currents equal to the outgoing currents. It's the same as the water flow. Wherever comes into the node has to come out somewhere. So I4 is where they're coming out, the current is coming out. So one of the laws that we're going to look at is going to be called the current law, and it states that the total current of charge entering a junction or a node is exactly equal to the charge leaving the node, or the current leaving the node, as it has no other place to go except to leave, as no charge is lost within the node. So everything enters the node equals to everything that comes out of the node. And the second law that we're going to look at is the Kirchhoff's voltage law, and it states that in a closed loop, the one that I showed you, different loops that you can make, loop network, in a closed loop network, the total voltage around the loop is equal to the sum of all the voltage drops within the same loop. So let's look at some of the questions and see when and how we apply the Kirchhoff's law. And also I want you to know that you usually can use the Ohm's law. It's most of the time the questions are easier to use with Ohm's law. Kirchhoff's law you have to use when you have more than one source, so more than one battery. With more than one battery, sometimes you have to guess in what direction the current is going to go. With one battery, it's easy. It's always going to go from the positive side of the battery to the negative side of the battery, the way they chose the current to flow. But with two batteries, sometimes you have to guess the direction of the current, and not always the one that you guessed is the right one. So with two sources or two batteries or three batteries or more batteries in the circuit, you will have to use Kirchhoff's law. So here's the first example that I want to look at, and they give you the loop in blue and the currents in purple, and they want you to find all the currents and the voltage drop on each resistor. You could use the Ohm's law the way we used it before, but I'm going to try to avoid the Ohm's law and solve this problem with Kirchhoff's law, and then we can check with Ohm's law. So let's look at this question. I have two loops. At first, I'm going to look at the purple part. Let me do it in purple as well, and use the law of currents. So I'm going to say that I1 is equal to I2 plus I3, because I1 is coming into the loop, into the node, I1 is coming into the node, and then I2 and I3 are coming out. So the one that is incoming, I1, is equal to the sum of the ones that are coming out. And you can choose the node anywhere you want to. In the future, they will not give you circuits with the direction of the currents. You have to choose your own direction of the currents. But here, since they already give it to you, I'm going to use the one that is given. And in the problems that we're going to be solving in the future, none of the loops and none of the currents will be given, so you have to choose your own. So this is the first law. And the second law, I'm going to do it in blue because the loops are in blue. So here is the trick. When you have to write the equations, follow the direction, follow the different books tell you different laws. I usually tell the students this way. As soon as you pass the element, copy the sign. So for the battery, I have positive side and I have negative side of the battery. Current is flowing from the positive to the negative. So when it passes through the resistor, I'm going to place which side is more positive and which one is more negative. So this side is going to be more positive and this side is more negative. The same for current too. This side is more positive, this one is more negative. And it will depend on the direction of the current that you're going to choose. Even if you choose the current in the wrong direction, your answer at the end is going to be negative. And again, for 9 ohm resistor, I have the positive side and the negative, because the current is going to go from the positive to the negative, and the direction is going to be to the right through the 9 ohm resistor. So now when I have the directions or the polarity of my elements, now I'm going to follow the loop. So it's the sum of all the voltage dropped on the resistors and the battery that is equal to 0. So I'm going to start with the battery. As soon as I follow the direction of the loop is going in this direction. So if I follow the direction, I pass the battery, I see the positive sign, so I'm going to write 6 volts. Then I come to the resistor when I follow my loop. It's a 4 ohm resistor. I pass the resistor and I see a negative sign, so I'm going to write 4. And in this resistor, I have current I1. And then I also see the resistor 9 ohm in my loop. And again, when I pass that resistor, I see a negative sign. I'm going to write -9. And then the current that is flowing through 9 ohm resistor is I3. And I don't have any more elements in this circuit. In this loop, I'm going to write 0. So the sum of all the voltages is equal to 0, and I times R is the voltage. And then I have the second loop, and I could choose a different loop. I could choose the loop that goes like this, but they already have the loop for me, so I don't have to make my own loops. So what I'm going to do is follow that little loop in there. So there's no voltage of the battery inside. So what I have is, again, I'm going to follow in the direction that they chose for me in this case. I'm going to pass the 9 ohm resistor, and I will have +9, and the current goes through it is I3. And when I pass the 5 ohm resistor in the direction of the way the loop goes, I'm gonna see the negative sign, and that is 5. And the current that is going there is I2, and that is equal to 0. So now I have the system of equations, and I can replace. So I want to have the system of 2 equations with 2 unknowns. I can replace my if I want to have only 1 and 3, or maybe 3 and 2, so I can replace maybe 1 with 3 and 2. So I know 1 is equal to 3 plus 2. So move 6 to the other side of the equation. So you have -4. And instead of I1, I'm going to have I2 plus I3. Then I have minus 9I3. And that is equal to -6. And then the other equation is -5I2 positive 9I3 is equal to 0. So I've got the system of two equations with two unknowns. Now I'm going to simplify the top equation. That will give me -4I2, -4I3, and -9I3 will give me -13I3. And that is equal to -6. I don't like all those negatives, so I'm going to times every single one term of this equation by -1, or change the sign, change the sign, change the sign. And then I have -5I2 plus 9I3 equals to 0. And I have a system of two equations, so you can solve for I2 and plug in instead of I2. I like elimination method in this case. So I'm going to times the top equation by 5, and then I'm going to have times the bottom equation by 4, and then I'm going to add them. So if I times the top equation by 5, I have 20I2 plus 65I3 and equals to 30. The bottom equation by 20 is going to give me -20I2 plus 36I3 equals to 0. And I can eliminate I2 by adding these two equations. So I add +20 and the -20, they cancel. And if I add 65 and 36, I will get 101. So that's 101. I3 is equal to 30 plus 0 gives me 30. So I3 is equal to 30 divided by 101, which is equal to 0.3 amps. So now when I know what I3 is equal to, I can go to any of the equations in the past that I had, and I can solve for I2. I'm going to use the bottom equation because it's equal to 0, so it's a little bit easier. So I have -5 I2 plus, and then we have 9, and your I3 is 0.3 equals to 0. So I2 is equal to 2.7 divided by 5. So I2 is equal to 0.54 amps. And since I know that I1 is equal to I2 plus I3, so I know that I1 is going to be equal to I3 is 0.3 and I2 is 0.54. So if I add them, I1 is going to be equal to 0.83 amps. So I found the current through every single resistor in the circuit. So I have every single resistor current found, and if you multiply by the resistance of each, you will have the voltage. So this is how you would use this problem using Kirchhoff's law. It looks complicated, but it is good when you have two sources, like two batteries. Let's do the same circuit with Ohm's law, and it's way easier with Ohm's law. But let's do it and solve the same question and get the same answer, so you will see that it doesn't matter which one you use when you have one battery. So using Ohm's law to solve the same equation, the same circuit. So I have the two parallel resistors, so I'm making them in yellow. It's 5 and 9. Their total resistance is 1 over plus 1 over. The result flip over, so the resistance of these two is going to be equal to 3.2 ohm. So I can replace those two with one resistor of 3.2 ohm, and then I have 4 ohm resistor, and I have the battery of 6 volts. So I can calculate the current I1. So here is the current I1. So I1 is equal to the voltage divided by the total resistance, which is 7.2. That will give me 0.83. That's the one that we calculated earlier. I did not delete it. I still keep it on the site. And then I can calculate the voltage dropped on the first resistor. So it's the current times the resistance, which is 4. So I times it by 4. And I get 3.33 volt is dropped on the first resistor. I had 6 volts. I'm losing 3.3 volt on the 4 ohm resistor. So between the next 2 points, they're marked C and D in the graph. I have to subtract, so 6 minus 3.3 will give me 2.67. So 2.67 volts shared for the other two resistors, and 267 divided by 5 will give me the current of 0.53. So this one is 0.53 amps, and we had it calculated before. So we found these two so far. And for the other resistor, 2.67 divided by 9 will give me 0.3. So this current is 0.3 amps. So you see, it's much easier using Ohm's law if you don't have two sources for voltage. But Kirchhoff's law works for all of them. Ohm's law works for some of them. So let's look at another question where we have two sources and where they don't give you the direction of the currents or the directions of the loops. So here is the next question, and in this question we have two sources. One is 5 volt and the other one is 3 volt connected the way they show. They chose for you the direction of the current, but it doesn't have to be this direction of the current. You can guess the direction of the current on your own. If you ever choose the direction of the current the wrong direction, then the current that you will get an answer is going to be negative, which tells you that you chose maybe the direction to the right, and actually the direction of that current is to the left. So let's look at this problem. So I see two sources and I have 3 resistors. Maybe I want to choose the direction of the loop right here in this direction, and I could choose the next loop in that direction, but I want to maybe choose the second loop to be maybe in this direction. So it doesn't matter which way you choose, but I'm going to choose one direction, the other direction. And all you have to do is to follow the direction, the signs of each element. They already placed for you the signs. So if they chose the direction of the current to the right, then they said, okay, this side is positive, this one is negative. The battery has this positive side and this negative side. Here they chose the direction of the current in this direction, so this is positive. It's going to go from positive to negative. And if they chose the direction of the current here down, then this side is positive, this one is negative. So at first we're going to look at the node and write the law for the currents. For the currents we have I1 is coming in, so I1 is equal to I2 plus I3, because I2 and I3 are coming out. And then the second one is the loop rule. So we're going to do the one that has 5 volt battery. I'm following the 5 volt battery, so 5 is going to be positive because as soon as I pass it in the direction of the loop, so the loop is going in this direction. So if I pass it in the direction of the loop, I copy a positive sign, so 5 volt. Then I have a negative 2, and that is I1. And then I have 8 ohm resistor, which is also negative, minus 8, and the current through it is I2, and that is equal to 0. And then for the next loop, direction I chose this way to be. So this one is going to be a negative 8. I'm going to start with the 8 ohm, so that's going to be negative 8 I2, and then I have negative 3 volts, and then I have positive 4i3 equals to 0. So I have the system of 3 equations, and I'm going to replace I1 with 2 and 3. So I1 is equal to 2 plus 3. 5 moves to the other side, and I have -2. Instead of I1, I have 3 and 2 added together, and then minus I2 and equals to -5. Again, if you don't like all those negatives, you change the signs for every single term. For the second equation, I can move my 3 volt to the other side. So I have -8i2 plus 4i3, and that is equal to 3. Distribute and simplify the like terms. So we will have 10i2, and then we will have 2i3, and that is equal to 5. And then we'll have -8i2, and then we're going to have plus 4i3, and that is equal to 3. We can times the second equation by the first equation by 2, and then subtract them to eliminate I3. So if I times the top equation by 2, I get 20i2 plus 4i3, and equals to 10. And then I have -8i2 plus 4i3, that is equal to 3. Then I am going to subtract them, because I want to cancel my +4 and the +4. So when I subtract them, I have +28 I2 equals to 7. So I2 is equal to 1/4 of 0.25 amps. So if this one is equal to 0.25 amps, I can plug it in into any equation. I'm going to plug it in into maybe this equation. Then I have, so this was my I2. Then I will have I3. So 4i3 is equal to 3 plus 8 times I2, which is 0.25. So 4i3 is going to be equal to 1/4 of 8 is 2, so that is 5. So your I3 is equal to 1 1/4, which is 0.25 amps. And then you have to find I1. And for I1, you have to add those two guys, so that will give you 1.5 amps for I1. So you see, without using Kirchhoff's law, this would be a difficult task to solve this the circuit to find all the currents. So Kirchhoff's law makes it easier. By using Kirchhoff's law, you can set up the loops and use the voltage Kirchhoff's law, and then you can do the nodes for the currents and then solve this problem. In AP Physics 2, I did not see a lot of questions related to these complicated calculations, but they do use the concept of it, where the sum of the currents coming in is equal to the sum of the currents coming out. So this is a common problem used when you have to show that you understand how the voltage drop in the loop is equal to 0, and then the current that is coming in equal to the current that is coming out. And I will stop my lesson on circuits at this point, and thank you for watching for this video and the previous ones, and I will see you in the future one.